Andrea Kess is really doing a very good job.
I tried to do so.
For our part-time students. And I really think that we are not successful with offering those types of programs and offering the services we do. And as I said, Andrea Kess is responsible for that.
Good, now I'm cabled. So now I have to tell you, I want to tell you a little bit about R&D at the study center in Pinkerfeld. As Gernot Hanreich told you, I'm responsible for the R&D here in Pinkerfeld, besides the responsibilities for the study programs. The title of the presentation is R&D at the University of Applied Science, Burgenland at Pinkerfeld. Impact on teaching and potential for cross-border networking. I want to start to discuss the importance or the motivation for R&D in the context of teaching of higher education. We are very convinced that doing profound R&D is a kind of motivator, a kind of motivation for the employees, because they are able to work on real up-to-date questions. They are able to stay in contact with the industry, and that's very important. So the employees can get an idea about the practical problems in the industry. They can take part in the solution of those problems, and that's also motivating them, and it's increasing their self-confidence, I think. It's also a way of regional technology transfer. It's an offer we have for the region to do research and development, and we do therefore on one side real science research, and on the other side technology transfer, things that we can do and that we do offer to the region. And I will give you examples for that later on. And it's also a potential, doing R&D is also a potential for the acquisition of information, for acquisition of data, which can be used for teaching. That's not true for all the projects, because we also execute or also do projects that are confidential with partners who don't have any interest that their data or that their information are being published. But on the other hand, we do also have projects which are public funded, and therefore we are able to use the data, therefore we are able to use the information for teaching and also for our publishing work. And doing R&D also offers potential for integrating students by either their internships, if they do their internships at our institution, or they can be integrated in projects doing a diploma thesis, or also start to be junior researcher if they have finished a bachelor degree or whatever. They can be a junior researcher at our institution. All those cases, they are employees at our institution and doing their contribution to our R&D. Just a quick information about the structure, about the organization. We do have the study programs here, Gernot Hanreich and me, and we do have, on the other hand, we do have processes, defined processes, and one process, the R&D, goes across all the study programs offered here, and as mentioned earlier, I'm responsible for that. And besides that, we do have a daughter company doing R&D. We are bundling all our project activities in R&D in this daughter company, Forschung und Technologietransfer Pinkerfeld GmbH, which I'm the head of. To give you an impression about the personnel, we do have approximately 35 to 40 employees here in Pinkerfeld in the area of, and about 2/3 or a little bit more than 2/3 of that is scientific personnel, and about 3/4 of the scientific personnel is in the area of energy and environmental studies. We do roughly 12,000 hours of research per year, man-hours of research per year. To give you an impression about the academic background of our workforce, it's a very interdisciplinary team. We do have engineers from energy engineering, process engineering, also agriculture, environmental engineering, electrotechnics, mathematics, and also we do have experts in building technology. So we have a very broad spectrum of expertise in our personnel, which enables us to do very interdisciplinary and broad activities in research. So what's the focus, the subject focus of our R&D? We tried, and I think we also succeeded, to find a research vision, a research focus covering both core competence areas which are located here in Pinkerfeld. First, the energy and environmental engineering, and second, the health area. And so we said we're doing research in the area of, in the how should I say, in the triangle of engineering, environment, and health. But we put the human being and the human well-being in the middle of it. So that's our research is centered around the human being, and we have three research focuses here. They cover very well our teaching activities also. The first one is in the area of building technology and building management. We do a lot of research work in the area of heating, ventilation, air conditioning, things like that. In the area of providing heat and coldness to rooms in a way to secure the well-being of the people, to secure the well-being of the users of the rooms, of the buildings, and also in a way which is ecologically sustainable and energy-wise efficient. So well-being in room conditions, optimization with regard to energy is important. Also, the clean room technology types of things are being dealt with in that area. We do a lot of simulation with computational fluid dynamics in order to optimize heating and cooling strategies and heating and cooling devices in that area. The second focus is the resource management and sustainability focus. Here we deal with energy and materials, also focused with decentralized energy supply based on renewables, and ecological assessment and life cycle engineering of processes. Things like climate protection and sustainability of energy provision energy systems is a real focus here. And the third focus of R&D is connected to the second competence area, health. So it's health promotion and health management. We also do have a lot of connects between the different research focus between the two competence areas. Yeah. I want to give you some examples of R&D projects, just that you see what type of things we are doing. For example, in the first research focus, we had a project going over 3 years where we had to develop a software for the dimensioning of indoor gas pipes. So you see, we first had to design a measuring setup in our lab, but then we had to realize it and in order to get the data as a basis for the software, and then we developed a software which is commercially available now. It's commercially available in Austria, and they also want to program or to implement something like that in Germany. So it's a real impact in the area of gas provision. Another project, computational fluid dynamics. We do a lot of validation work here also, because you can simulate anything. If the model is not validated, the result or the essence is nothing. So we do always compare. We also always go along with experimental data, validating our models that we use, and then do the simulation. So that goes hand in hand. And we have a very extensive measuring equipment. Here it's a particle image velocimetry, very expensive device, but enabling us to measure, for example, the velocity and direction of an airflow in a whole area. You see, that's measured in one shot, and therefore we can validate and improve models. So you see here the measuring of a flow area, and then the simulation with a standard model which doesn't fit very well. And if we increase or improve the model, we get very close simulation results to the reality. Another point was that we a lot of projects deal with bench scale experiments. Here we had to implement the bench scale stand in order to see whether we could simulate fluid as bed. And we had to validate the models and got those results, which were very good results for that type of thing. Other projects are dealing with climate relevance of enterprises or assessment of greenhouse gas emissions along the gas provision network, or also life cycle engineering of different heating systems. Now I want to tell you what can we do across the border, so to say, cross-border networking in the area of R&D. We did have some projects, Interreg financed projects, like this project is. We did have this in the R&D also, and I want to tell you about two examples. There was one example really very much on the implementation side, not too much research work, but very much on the implementation side, what can we give the regions? And this was a project called Nordic Walking Eco Trail. And we had 3 regions. That was our region here in Austria. Then there was a region in Italy, another one in Germany. And we developed Nordic walking trails for any of those regions. Nordic walking trails which got implemented by now. And the idea was to look at the ecological specialities of the areas and to combine the ecological specialities with the health effect of Nordic walking. And that was done for all 3 regions. There has been implemented a water adventure trail in southern Tyrol. There is a spring trail in Burgenland, nearby in Bad Tatzmersdorf, and there is a so-called mill trail in Germany. So the advantage to the region is that there is a creation of new attractions for tourists. There is an increase of the health tourism attractivity, and it's also an optimum combination of health and nature. And there is a large network of Nordic walking eco-trails that has been started. Just a few details. You see here, that's the setup of the Nordic Walking Eco-Trail. They have a length of about 5 kilometers, so you walk about 75 minutes. In that case, there is no height difference. and there's some stations and rest areas. On these stations and rest areas, we developed these types of tables where specialities in the ecology are being explained. In the case of Burgenland, we do have groundwater springs of a special type, and that's been explained there. And it's also explained the health effect of Nordic walking and how it should be done. So that's how this has been realized, and it was, as I said, Interreg financed. A second project I want to give you an insight in is a so-called photovoltaic simulation tool, which can be done online. So here we had also three partners. That was us, and that was the company Fissmann producing photovoltaic modules, and also a research entity in Italy, which is called Euroc Research. And the aim and objective of that type of project was the development of a usable online photovoltaic simulation program for the dimensioning of grid-connected as well as autonomous photovoltaic plants. And the tool should allow a rough dimensioning for the dummy user, I would say, and also allow a very detailed dimensioning for an expert. So why did we do this? Because photovoltaic modules are still very expensive, and a detailed engineering or planning prevents over-dimensioning and also gives you an exact result on the expected power generation. There are a lot of simulation programs available, but many of those are not really easily available and have a high price, and the extent of the usability and functionality of those programs is not very, very good, and the algorithms used are not laid open, so you don't really know how the result is being generated, and they are also not validated. So our aim was to create a tool providing all those things, like it should be validated, it should have an open, transparent way to generate the data, it should be functional, it should be applicable for different types of users, and it should be available. And therefore we implemented it online. It can be accessed at our homepage, and everybody can use it for online simulation of the photovoltaic modules to be planned or to be built. We do have equipment for the validation of this simulation program. As you might have seen coming in here, we do have our own photovoltaic plant on the study center here, and so we could do measurements and compare it to the simulation. We also do have meteorological measuring equipment here on the study center in order to get the meteorological data as an input for the simulation tool, and that was the prerequisite to do the validation. There has also been validation of a larger plant in Italy, and the conformity of the measured values in the pink line with the simulated values of the blue line, as you can see, is a very good conformity. So we can say that the results have been achieved, or the aims have been achieved. So that was about it, about our R&D at the study center here in Pinkerfeld. I think these types of Interreg projects do pose a lot of potential for cooperation, and also all the other European finance programs in the framework, 7th framework, or we do also have national finance projects where you should deal with international partners. So I see a lot of potential, and I think real-time networking also plays a role in having a good cooperation in those types of projects, because what we saw, the communication in those types of projects across borders and over long distances is a real problem that has to be solved. Thank you very much. So I believe we can have a break now. The break, the coffee, the drinks are just in the next room. And I invite you to just have your break now. Thank you.